Hello guys, okay, I received some requests to solve some logarithm questions. Okay, so I picked some questions on my own, okay, and some questions some people sent. So today I'm going to do all the videos. Yeah, please take time to watch and enjoy. Okay, graph the following. I'm supposed to graph y is equal to 2 minus log x minus 1 to the base of 3. And again we have another question, y is equal to that is 1 over 3 to the power x plus 1 and then plus 2. So a plus 2, that's a constant, it's not a power. Let's first graph the first one. We're graphing an equation which is saying we're graphing an equation y is equal to 2 minus log x minus 1 to the base of 3. Okay, so what do we need to know when we're graphing something like this? So graphing a log, this is a log. As you see, there's a log inside. When graphing a log, one thing that we have to really keep in mind is that when graphing a log, we have to know that we need to find the vertical asymptote, which is the VA. The vertical asymptote mostly covers where we have to solve for xi. Okay, that is the vertical asymptote. So how do we find the vertical asymptote? The vertical asymptote is found by making the argument or making the argument is equal to 0, because a log doesn't support 0 or doesn't allow 0 to be a to be a base or to be an argument. So if you are wondering what's an argument when he's talking about so when you have a log the way it is the way it is so this log has this number which is known as a base and this number which is known as the argument. So this is the argument and this is the base. So let me just write there, this is the argument and this is the base. Okay, so if you're wondering base, this base comes from the exponent When we go to exponent, you're going to know that this number works whereby it is if something like 3 to the power 1 So 3 to the power 1, 3 is always the base, and then the power, this is called the power, right? Yeah, so in this case, this same base is the one which comes here and in the log, and then with this as the answer, let's say this is 3 to the power 1 was equal to x minus 1 So this is the answer for 3 to the power 1. So as we are finding the vertical asymptotes, we know that vertical asymptote is not equal to 0 That's because there's nothing that we can power 3 to give us 0. That's why we find this vertical asymptote to be the asymptote Yeah, so we always equate the argument is equal to 0. The argument is always equal to 0 because there's no number that you can power a 3 to, or any other number. There's no power of 3 of anything that can give us 0 unless the base was 0, because at least no if base 0 to the power 0, 0 to the power 0, this should be 1. Yeah, this should be 1 unless otherwise. But yeah, let's find the vertical asymptote. At least you know something now. Okay, so we equate the argument is equal to 0. So the argument for here, it is x minus 1. So x minus 1 is equal to 0. So we don't want it to be equal to 0, where our x is equal to 1. So this one is saying that our vertical asymptote is starting from 1. And in logs, once you find your vertical asymptote, meaning the rest of the sketch is going to be done on your right hand side. It will never go to the left hand side. It will always be done on the right hand side of the asymptote. Yeah, the asymptote sometimes can be negative, can be positive, but always after finding the asymptote, the graphing is going to be done on the right hand side. We are going to see how it's going to come out. Okay, let's continue. So the second case is where we find the coordinate So finding coordinate, you can draw a table. You also find your coordinate Okay. So x, y, you make a table. Yeah. So to make this table short and simple, we don't have to make a lot of numbers for xi. We don't have to give x many numbers, because some numbers will really require a lot of challenge. Require some challenge. They are real. Yes, they can happen, but they require a lot of challenges. Because in this case, don't forget we're graphing and we're not using a calculator. So if you find some things with my point, it will be very difficult for us to solve, especially at least something like half you can solve. But again, this thing deals with powers. Don't forget I've said something high. So in this case, we're saying what number do we have to raise this 3 to give us x minus 1. So we're guessing a number. So imagine if the number is 1.5. Are you going to know 1.5? What is 3 to the power of 1.5? So because of those 1.5 and other numbers, we don't want to have negative numbers. We don't want to have dotted numbers, or let's say dot fractions, or decimal fractions in short. Okay, so to just guess properly, we're going to equate our denominator. The denominator, our argument. We're going to equate our argument is equal to 1, and again is equal to the base. The base, don't forget the base, not is equal to 2, is equal to the base. So the argument is x minus 1. That's our argument. We're going to equate it to 1. Again, the same argument, we're going to equate it to the base. Okay, and then for this we solve for the x, and then we replace where the x is. So let's try to do that. We have here, for this one, we're going to have x minus, it's going to be x is equal to, this is going to be x minus x, x, this is minus, so it will be plus this side. Okay, so it's going to be x is equal to 2y, x is equal to 2, so we can put 2 here. Okay, and then for this one, we can say x is equal to 3 plus 1i, where x is equal to 4. Okay, so x is equal to 4 here. We can just end here. These other boxes can be filled in if you feel, I'll show you how you can fill it in without any trouble. Okay, so we have these two coordinates, these 2 points. Let's find their coordinates or their corresponding y point. So the y number of this number, so since we have equated it to, we said our x is equal to 2y. So let's try to find the y. So we have this equation. Y is equal to 2 minus log x minus 1 with a base of 2. Okay, base of 3. Yeah. So in this case, what can we do? So in this case, we can say we're replacing x here. But that's a long process when you start replacing x here, because you have already said that this whole thing you equated it to 1. Don't forget this whole thing you've equated it to 1. Okay, so there's no need of you trying to find x again, or trying to replace x again and trying to find 2 minus 1 is equal to 1. Okay, so just get this one you have equated it to. So we're going to say y is equal to 2. My pen is finished. Okay, we're going to say y is equal to 2 minus 2 minus what? 2 minus log 1. You equated your argument to 1. Okay, so to the base of 3. So now you're asking yourself, what number should what power should I give this 3 to have a number to have a 1? And that is 0. So when you equate this 3 to 0, you're going to have, when you say 3 to the power 0, that is going to give you 1. So you're going to have your log y is equal to 2 minus 1. Yeah. Oh, sorry, minus 0, not minus 1, minus 0. Because, minus 0, don't forget I. So in this case, we're going to have y is equal to, we're going to have 2 here. Okay, so we have 2, 2 in short there. We have 2, 2. So we have here also, we can say log, start with y. Y is equal to 2 minus log, as I said earlier, we equated our argument to 3. So we're going to put 3 there, and then to the power, to the base of 3, with a base of 3. So I'm going to say y is equal to 2 minus, what number can we equate this 3 to have a number of 3? And that is 1. So 3 to the power 1 will give us 3. So we're going to say that is 1. Whereby we're going to say 1 minus 2 minus 1, which is going to give us an answer of, that is 1. So we put our 1 there. So for these others which I didn't say anything, or I didn't do anything there. So these are numbers where you can try to guess by saying that, since you know how this pattern is going. So if you try to put your discriminant to be something like to be 9, to say that what number can I equate this 3 to give me 9? Okay, what number can I equate this 3 to give me 9? And that number is what? That number is there. It is 2. Okay, it is 2. So there's a number which is 2. Okay, so I can use that too. So I'll say I'll now find for xi using 9. I'll say the discriminant is equal discriminant, which is not discriminant, sorry, the argument x minus 1 is equal to 9. So I'm trying to find for x now, because I replaced 9 where there's a log I. Okay, or where there's a log. So x is equal to that is 9 plus 1 I, where x is equal to 10. So when x is equal to 10, y is equal to what? Y. So now I'll say, I said y is equal to, y is equal to 2 minus 1, or minus log 9 3i. I equated the argument to 9. Don't forget. So 9 to the base of 3. Where I say that the number which can give me 9 here is I said 2y, it is 2. Where your y is equal to 0. Your y is equal to 0. Yeah. Okay. So you can put there 10 with 0 there. You can also find others, but as you can see, they're increasing, and when they're increasing, don't forget we're not doing these things. We're drawing our own graph and we're doing our own things, so we can end here and do our graph I. Okay, so our graph, how is it going to be? So with the coordinates that we have, we have coordinates. First of all, let's go to the asymptote I. The vertical asymptote that we have, vertical asymptote. Don't forget, you don't find the horizontal asymptote in logs, only vertical asymptote. So vertical asymptote that we have here is 1, not -1. It's 1i. As you can see, it is here. It's 1. I'll go to 1 and put my vertical asymptote. Vertical asymptote is just a line or a limit, a line which is showing us that there's a part where this log can work and the part where the log cannot work. So this log can only work to the positive hand side after the, as I said earlier, the positive hand side after the asymptote. So the positive hand side, or which is this side, the positive x, it can only go this side, but it won't go this side to the left hand side, where it cannot go that side. It has to be going to the right hand side. Okay, so that's the asymptote. It continues if the graph increases I. Okay, so we had our coordinates. The coordinates, we have 2, 2 is somewhere here, as I can relate. So 2, can be somewhere here. 2, that is 2, there's a 2 here, there's a 2, 2. We have 4, 1. 4 is here, and 1 is somewhere here. 4, 1 is somewhere here. 4, 1 is there. And then what we have? We included 10, 0. 10, 0 should be somewhere this side, which I never included I. So we can go. So how do you go about this? As you can see, as it's going I, this one is closer to the graph and this one is at least a part I. That means it's showing us that the pattern is going like this. It is going like this. So it will go and meet somewhere that side. Okay. So this is our graph. That's how it's going. So this graph will never cross the asymptote. It can only be close, but never cross the asymptote, or even come to be to the asymptote side I, or to be equal to asymptote. So this is the graph. You just name it. This graph is we said y is equal to 2 minus log x minus 1, which is a base of 3. You are done, and you'll get all the 5 marks. That is the graph for that. Okay. Okay, guys. Okay, this is the second question, which is about the exponent I. So it reads, so we're sketching y is equal to 1 over 3 to the power of x plus 1 plus 2i. Okay, so in this equation, what do we have to know? So in this equation, as I can see it, okay, always we are going to treat the constant. We're going to do the same thing as we did for the log I. So as if you watched the last video or the previous video, I say that logs and exponentials I, the opposite I, they contradict. Can I say contradict, or okay, they're opposite each other. They're opposite each other, or they complement each other, whichever word you can use, just to say that they are like opposite I. So what you do here is what you could find. Could be the answer for the log I. So for the log, we started by saying we find the vertical asymptote I. Now for the y axis, for the exponentials, exponential, we're going to find the horizontal asymptote I. So because these guys are opposite I, the other one we had found the vertical. This one we're finding the exponent, the horizontal asymptote. So how do you find the vertical asymptote for this one? So vertical asymptote for this one always comes from the constant. You check your answer or your equation if it has any constant. The constant is the one I which has a definite power I. Okay, as we can see, this one I, this is 1 over 3 x plus 1 I, and we have 2 here. This 2 also has a power of 1, we know that I, so its power is definite. Okay, but this one, the power is not definite. This is, it has x in it. Okay, so we don't know what its power is. It can be 2, it can be 3, it can be 4. It's, it's not fixed. So for that, we're going to get the constant as our horizontal asymptote. So in this case, since horizontal asymptote deals with yi, we are going to say y is equal to 2. So the constant. So if you are asking, if you have something like 2 to the power xi or 2 to the power xi, this one, if it's just y is equal to 2 to the power xi, please just say that our horizontal asymptote for this one is equal to 0, because there's no number, or there's no number behind or in front which has a definite number, a definite power. So because of that, we're going to say our horizontal asymptote is equal to 0. But for this one, since 2 is there and it has a definite power of 1. Yeah, that's why we're treating it like that. Okay, so we have this. Okay, how far can we go? Okay, so the second thing is to find the coordinate. To find the coordinate, the best numbers to use are always 0, 1, 2. They're the best numbers because they're easy to calculate. So let's create our table of content. Yeah, but as you know, you can go as far as you can, but just to make it fast, because yeah, it's always about time. These things, it's not that you have all the time to graph whichever way you want. So you have let's choose x is equal to 0. X is equal to 0. We're going also to choose x is equal to 1, and we can also choose x is equal to 2. Yeah, as far as you can go. Okay, so in this case, we're going to have y is equal to we've chosen our x as that I. So 1 over 3. If our x is 1, is 0, meaning our answer is 1 here. If our x is 1, if our x is 0, meaning we're going to have 0 plus 1 plus 2i. Okay, so in this case we have y is equal to in this case, what can we say? So this is 0 plus 1i, so we have 1 over 3 with the power of 1 plus 2i, and you know that the power of 1 is just the same thing as the number behind I. So 1 over 3 plus 2. So in this case we can put 1 down here. Okay, so after putting 1 down, what are we going to say? So since we have put 1 down, we just make a fraction I. Y is equal to, we have 3 down, and then we have 1 plus 6i. Yeah, so you are saying that 3, yeah, 3, and then how many? So 3 into 3 is 1i. So 1 times 1 is 1. 1 into 3 is 3. 3 times 2 is 6i. We have that, which the answer is going to be 7 over 3. Yeah, 7 over 3. If you want to put it in point, you can put it also in point because you are graphing. Yeah, so just make it in point to graph. This is going to be a number which is 2 remainder 2 point what? 2, that means remainder 1. So 2 point, that's like 10. That's like 10. So 3 into 10, that's again 3i. That's 3. So 2.3 point something again. So we can just get 2.3 in this case. 2.3, we get it. We go to that number is what? That's 1i. So if our x is 1, y is equal to 1 over 3, where is x plus 1i plus 2. So in this case we're saying y is equal to, if our x is 1, meaning we're going to have y 1 over 3, or 1 over 3, yeah, 1 over 3, 1 plus 1 plus 2 down here. So this is going to give us a number of 2 here, power of 2. So we have this 1 over 3 with a power of 2 plus 2i. So this one is going to be y is equal to, so this is 1 power 1 is 1, and 3 power 3, oh, 1 power 2 is 1, and then 3 power 2 is 9i plus 2. Okay, so this one is going to give us an answer of, if we try very hard, if it we try, we are going to find the number of, so 9 is going to be the denominator, whereby we are having 1 plus 18i. So the answer there is 19 over 9, which is the same as, that is it 2? Yeah, that is 2 remainder what? That is 2 remainder 1i. So that's going to be 2.1. Again, it's going to be 111i. So we can just say 2.1. 2.1. Is it making sense? Yeah, 2.1. So we put our 2.1 there. Yeah, 2.1. So the other number we had said 3i is 3 or 2. So we had said 2 here. So if our x is 2, y is equal to, I'm trying to make it like that time. Y is equal to 1 over 3, and then we have 2 plus 1 plus 2i. Okay, so we have y is equal to, here we are going to have 1 over 3. This is going to be 3 on top I plus 2. So we're going to have y is equal to 1 to the power 3 is 1i, and 3 to the power 3, that should be 27. Okay, the number is going to be increasing so big, but let's just find it first. You see, this is 2, so we can put over 1 there and say our denominator is 27. So whereby we're going to have 1 plus, so 27 times 2 there, 27 times 2, that is about 7 remainder 1i, and then that is 4, 5, so 57. We're going to have 57. So since this is 1, we're going to have 56. So we're going to have 58, sorry, 58 over 27. This number is going to be, we said it can be 2i, 2 remainder numbers there. Okay, so as I can see, for y is constant. I don't know why it's constant, but okay. Yeah, it's constant. Okay, let's try to see how far we can go. Okay, but though, yeah, so this is going to be 2.1 again, which is going to be 0 point something I, 2.0 something, 2.00 something I. Okay, since we're not using a calculator, let's end it there. Okay, so to the graph. Let's go to the graph now. Okay, so the graph, we had our y asymptote, which is 2. Our y asymptote is 2. We go to 2. I think 2 is here. This is our at y asymptote, sorry. Our horizontal asymptote. Horizontal asymptote is 2. We have 2 there. Okay, so this side and that side, right? Okay, so what are we doing? We're graphing again. So graphing. So our points, as you can see, our points are here. So our vertical asymptote was 2, and then our points that we have point which is 0, 2.3. So 0 is 0, 2.3. That is somewhere. This is 2. So 2.3 is somewhere here. 2.3 is somewhere here. As you can see, people, this graph is not touching 2. So this one should not touch 2. That's why it's decreasing always, because it shouldn't touch 2. So it's somewhere here, and then we're having another number which is 1.2.1. So it's decreasing. It has become somewhere here. Okay, 2, 2, is it 2 point something I, which should be somewhere near there, but not exactly there. So this graph, how is it going to be? So this graph, according to the way it's going, so it's showing me that it should go something like this, but shouldn't surpass that, as I can see. Okay, because if we try to put, did we put 1? We tried to put 1, let's try to put -1. If our y was -1, let's try to see how it can go. If we go to the negative side, if our y was -1, we could have had 0 here, where the answer is going to be 1. So if our y was negative, our x was negative 1, our answer could have been, in fact, our x would have been 2, because this thing could have been 1. If this is negative 1, this could have been 0. This could have been 0, giving us only, meaning this power, everything here is going to be 1. It's going to be 1. So 1 plus 2, which is 3. It's going to be 3. So 3 is somewhere here. Okay. That is showing us that our graph is 3 point some. I said negative 1. Negative 1, 3. Yeah. So this is actually working, saying that the graph is going like this. The graph is going like that. Okay, but it won't touch the asymptote. It won't touch the asymptote. It will just go like that, going that side. Okay. Yeah, this graph, what's the name of the graph? The graph is y is equal to 1 over 3 x plus 1 plus 2i. That's the graph's name. Okay. Yeah, that's the graph. Please, if you have a different kind of graph, if you draw and you have a different kind of graph, you can inbox me, we discuss. Okay guys, so the final question I'm going to do here is a question dealing with what's known as reflection. So since we say that the x and y graphs the logs and the exponential graphs, they are almost as if they are reflection of, not even as if they are reflection of each other. The reflection of each other on the x is equal to yi. Yeah, the reflection of each other on that line. So this question is saying graph f of x, which is log x, which has 1 over 4 as a base, by reflecting the graph of g of x, which is 1 over 4 to the power xi, across the line y is equal to x, as I said earlier. So y is equal to x. So that line, we're going to make a reflection. So what they're asking is that we are graphing f of xi, we're graphing the log by reflecting g. So in short, we're drawing f of g and reflecting, and then now make a reflection of it, so that it can look as if I've drawn the log I, or the f of xi. Yeah. So in this case, they're not going to be there looking at you. So if you want, you can draw both of the graphs. You draw for the you calculate for the log, and then you calculate for the exponentials, and then you just put them on the graph. Or if you want, you can just draw for f of x and then try to make a reflection of it. It's simple and straightforward. Okay, let's try to do it. Okay, in this case, you can just draw both of the two graphs. You can draw both of the two graphs. So let's draw the two graphs. So we can start with the f of x, if it will work. So f of x is equal to we said log x 1 over 4i. So the same way as we always do things, we have to find the vertical asymptote, the vertical asymptote. So the vertical asymptote for this one is where x is equal to 0, because x is the only argument there. So x is equal to 0. We are done with the vertical asymptote. What about the other numbers? So we're going to equate x is equal to 1. Again, x is equal to what number? We can say x is equal to the discriminant 1 over 4, or the base I. So now we calculate for x is equal to 1. So x is equal to 1, meaning we're saying that log 1 of 1 over 4. So what power can we give this number to get what? To get 1i? And that answer is 0. So for this one, so f of x is equal to 0 for it to get 1i. Okay. For this one, what power can we give this log x? Oh, so this is we're saying x is equal to 1. Or x is equal to 1 over 4. X of 1 over 4 base 1 over 4i. So this base and power are the same, meaning the answer is always going to be 1i. The answer is going to be 1. So what power should we give this one to get 1 over fi? That is itself. We put 1 there to have the same. So we have these two coordinates. We can make them as a coordinate I. So the coordinates that we have here, we have, let me put them here, our coordinates. Our coordinate is x, y, whereby we have said x is equal to 1, again x is equal to 1 over 4i. And then we've had what? What have we had? We've had we've had 0, we've had 1. 0 and 1. Okay, let's keep that in mind. Okay, let's try the exponent one. The exponent is g of x is equal to we have 1 over 4 of xi. So as you can see, this one doesn't have first of all, it doesn't have a constant I, or it doesn't have the one we are saying that a number which has a fixed power. So we can just say its horizontal asymptote is equal to 0 also. You see, 0, 0. Okay, that makes sense somehow. Okay, so to make the line or to graph the line, we say that we can try to say what to put x as we can to put as many values of x as we can to calculate them so x, y. So let's try the same ones. We try 1 in fact, let's start from 0, 1, and maybe 2. Let end part 2. So if we have g of x, which is 1 over 4, if we put 0 here, meaning we're going to have the answer of 1. So 0 is going to give us 1. Okay, if we try 1 here, if we try 1, g of x is equal to 1 over 4. If we put 1, this answer is going to be just 1 over 4. 1 over 4. So as you can see the coordinates they are interchanging each other. When this one was 0, this one was 1. But when x is 0 here, the y is 1. Are you seeing the way they were interchanging? Okay, so meaning this is they're making a reflection. So already we know what to do if I may say. Okay, so it's like we're making an inverse of this. If you know how to make an inverse of a graph an inverse of that's what making an inverse of this. Okay, so it gave us 1 over 4. 1 over 4. Let me just write it like that. There's no space. So 1 over 4. And then if we try 2, we're going to have a number going now further. This is going to be 1 over 16. 1 over 16. 16 is too big to even plot, but let's try to end there, because I think the numbers are going to be increasing that side, and we don't want our graph to be that much complex. Okay, so we have these numbers. As you can see, if we try to end, we end with 0 and 1. We've come to discover that this for f of x, which is 0, 1, 0, 1, and 0,1 and 1 over 4. As you can see, if we invest this that's why investing it means we're making it we're changing its coordinate. We're changing the x to become the y and the y to become the xi. So that makes up the coordinate of g of x, as you can see, where we have this is g of x and this is f of x, where we have these coordinates. We have these coordinates here. We're going to have 1, 0, and we're going to have 1 over 4, 1. You see? So in short, if you find 1, do not waste time on this thing. If you just find 1, if you can solve for 1 of these 2, just make a reflection of it, meaning make the x coordinate become the y coordinate and the y coordinate become the x coordinate, and then you go to the graph. So let's go to the graph. This is the graph. The asymptotes. So both the asymptotes, we have the x and y. So both are 0. So this is where the 0 is. Both are 0 and both are 0. So in that case, there's no need of worrying a lot. So let's plot the first one, which was the f of xi. F of x. F of x started from where? F of x started with 1, 0. 1, 0 is somewhere here. 1, 0 is here. This is 1, 0. We also have 1 over 4, 2. 1 over 4, 2, that means it's somewhere here. 1 over 4, 2, 4, sorry. 1 over 4, 1. 1 over 4, 1. That is should be under the 0. So because 4 into 1, it is 0.25, 0.25. So it should be somewhere within the between 0 and 1. So somewhere here is where to be, somewhere there, somewhere here. Okay, so if it's somewhere here, as we can see, that means this graph since this is the asymptote, this graph is looking as if it's going somehow. Oh, this is asymptote, sorry, this is asymptote for the vertical one. So this graph is going somehow like this. It's going somehow like this. Okay, it's going somehow like that. Okay, so what's the reflection of that? Me, I'm sure it should go something like this down here, but let's try to see. We had the g coordinates. Let me just say this is the f of xi, which is equal to log 1 over 4, and what do we have again? 1 over 4 xi, 1 over 4 x, and then let's try to see the g of xi, where we have 0, 1, 0, 1, 0, 1, that is here, that is 0, 1, 0, 1, that is there. And then what do we have again? We have 1, 4 somewhere here, so it should be somewhere here, okay, somewhere here. I can put it somewhere here. Okay, I can put it somewhere here. It's not here, sorry, it's somewhere here. So this is really telling us that the graph, since it's the x-asymptote, and you can see that this is up and this is down, this is up and this is down. This is telling us the graph should be going something like this. Okay, it's going something like that. And I've plotted it, as you can see. Although, yeah, it's not making the reflection that you had expected, but yeah, this is what it has given us, and yeah, the confusion is over. So this is the asymptote. Sorry, it should have gone something like this, not going up again. It's trying to touch the asymptote, but it won't touch the asymptote, and to go up this side like that. So yeah, we've plotted it, and the name of this graph is g of x, which is equal to 1 over 4 x. Yeah, we've plotted it. That's how you plot that reflection. Okay guys, thank you very much for watching.